A question here, evaluate or find the integral of dx divided by x squared square root of x squared plus 1. Whenever we are evaluating integrals and we see a sum or a difference of two squares, we get to substitute trig identities there. In a case where we've got a sum of two squares like that one, what are we going to substitute? Well, we use the identity for tan. We know that sec squared theta is the same as 1 plus tan squared theta. And this I can also write it as tan squared theta plus a 1. So we can see that this one is in the form, just the one I've written here, that is x squared plus 1. That means where there is x squared, we can replace with what? Tan squared. And so for this one, we say x squared is equal to tan squared theta. And I can find what x is. What to be x? I'll square root both sides. So x is going to be tan theta. At this point, let me get to find the derivative. Well, dx is going to be equal to the derivative of tan theta. This is a always known derivative, is always sec squared theta. To find this one, well, we can follow the video in the description. And because I've differentiated, I'm going to put d theta this side. It was supposed to be dx over d theta, but I wanted to have dx sub the formula. And so this is going to become the integral where there is dx. We know what dx is, sec squared theta d theta. And that will be divided by where there is x. Well, what is x? X, we can see that is tan squared. It's not just x, this is x squared. So where there is x squared, we're putting tan squared theta. And then we're going to have square root. Again, where there is x squared plus 1. What is x squared plus 1? Well, we've already seen that x squared is the same as tan squared. So that is tan squared plus 1. And where there is tan squared plus 1, we can put the identity, which is what? Sec squared theta. And what would be the square root of sec squared? Well, the square root of sec squared is simply sec theta. And one sec on top can cancel with one sec down. So just remain with one sec on top, sec theta d theta. And that will be divided by tan squared theta, because one sec, has cancelled out. Now from here we are going to simplify this. On top we have got sec, and we know that sec is 1 over cos theta. Instead of me saying over, let me say divide by. And then down we have got tan squared. What is tan squared? It's the same as sin squared theta divided by cos squared theta. And this I can write as 1 over cos theta times cos squared theta divided by sine squared theta. So one cos can cancel with one cos on top. So this will remain the integral of, on top we're going to have only 1 cos theta divided by, down we're going to have sin squared theta. Remember, I didn't cater for the d theta which is on top, so we still have a d theta there. Now that we have got this, at this point I can use u substitution. So I'll say let u be equal to sine theta. So what is going to be du? So du is going to be equal to the derivative of sine. When we get to differentiate sine, we always get, okay, let me just show how we get that. Take the positive x-axis as sine, the negative x-axis as negative sine, positive y as cos, negative y as cos, negative cos. So differentiating goes in this direction. So when you differentiate sin, you get a what? A cos. So therefore du is going to be cos theta d theta. Now let me make theta sub to the formula. D theta. So that is going to be du over cosine of theta. So I'm now going to say this is going to be the integral of cos theta divided by, where there is sine, I'm going to put u from what we can see here. But it's not only sine but sine squared, so it will also be u squared. And where there is the theta, I'm going to put du over cos theta. See, this cos theta and this cos theta will cancel out. That will be the integral of 1 over u squared du. And this we can also write it as the integral of u to the power negative 2 du. How do we integrate u to the power negative 2? Simply add the 1, that becomes u to the power negative 1. Like negative 2 plus 1 is negative 1. And then divide by the same negative 1, just add a constant c. So we can simplify this one further. And that will give us negative u to the power negative 1 plus c. Like this negative 1 can go there. So it just be negative 1 negative u to the power negative 1 plus c. Now I can take the u down because it's negative. So that will be negative 1 over u plus c. And then you put back where there is u. That will be negative 1 over, what is u? Well, u is sin theta, so that will be sin theta plus c. But here we add x. We are not talking about sin and the theta. Okay, we need to express it in the same way it was given in the question. But what did we say x was? We said x squared was tan theta, and so x was x squared was tan squared theta, and so x gave us tan theta. And I can also write this as tan theta is equal to x. We know x is the same as x over 1, and I can put this in a triangle. So if this is the angle theta, how do we find tan? Tan theta is given by opposite over adjacent. So the opposite is x, adjacent is the 1. And how do you get to find the hypotenuse? The hypotenuse is 1 squared plus x squared and then square root. So that will be the hypotenuse. And so where there is sin theta, how do you find sin? Sin is given by sin theta is equal to opposite, which is x, over hypotenuse, which is the square root of 1 plus x squared. So this is going to be negative 1 divided by, where there is sin theta, I'm going to put x divided by square root of 1 plus x squared. And then this is a plus ac. And this we can just write it in simple form. Negative 1 over this is the same as negative 1 divided by x over square root of 1 plus x squared. I can multiply here and these are going to swap directions. So this is going to be a negative square root of 1 plus x squared divided by x and then plus ac. That is the integral then for this question.